All right. Okay. Oh, welcome, guys. Welcome, guys. All right. My name is Christopher Pogome from the Chem Lab. We're going to be looking at chemical laws and their verification. The first law we have here is, first of all, let's understand this. Chemical laws. Now, when we talk about chemical laws, what are we actually talking about? Now, chemical laws basically has to do with what are those rules that you would have to follow when you are dealing with chemicals. What are those rules that you have to follow when you are dealing with what? Chemical. That's what chemical laws basically is all about. What are those rules that you have to follow when you are dealing with chemicals? What are those rules that you have to follow when you are mixing chemicals? What are those rules that you have to follow when you are working with chemicals in terms of measurement, in terms of calculations, in terms of experiments? Okay, these laws are very important because they are things that have been proven over time and they have been found to be what? Authentic, and they have been found to work. Okay, that's why they actually call them laws. Exactly. Not hypothesis, not theory, but what? Laws. If you cast your mind back to the foundation of chemistry, they say we have how many scientific methods? We have observation, we have hypothesis, we have experiment, we have theory, and then finally we have what? Laws. Exactly. All right. So now, law of conservation of mass. Law of conservation of mass. Now, what is the law of conservation of mass basically talking about? Now, the law of conservation of mass is talking about the fact that energy, you cannot create it, you cannot what? Destroy it. You can only change it from one form to another. Or it's saying matter, you cannot create it, you cannot destroy it. You can only change it from one form to another. Now, somebody might be asking, what about paper? That so-called paper, when you set it ablaze, because paper is matter, as we all know, matter is anything that has what? Mass and occupy space. And mass is a function of the particles that make up what? The substance. Is not so? Good. So now paper is made up of different substances. Is it not so? One of which, the major, carbon, right? So now this paper, you set it ablaze and it burns. It turns to ash, right? The ash is the new product that it has turned to. Now the question is, have you not succeeded in destroying that paper? Have you not succeeded in destroying the paper? And yet they are telling us matter is neither created nor destroyed, but can be changed from one form to another. Now, the truth is this: you have not destroyed the paper. You haven't. Why? Because the components that makes up that paper, they are still there. They are still there. They are still there. Only that some of them change to what? Gas. Remember, change from one form to what? Another. The paper is solid. Now, when it changes to a mixture of gas, uh, other lesser solid. Are we getting it now? So, for that paper, even if you set it ablaze, it is not destroyed. Eh, it just changed from one form to what? Another. So, it means that when you are mixing chemicals together, eh, whatever you will form, whatever will make up the new substance that you form, those makeup will not be different from what you mix together. Are you getting it now? So if I take uh, salt and water and I mix them together, eh, I have formed a salty water. Is it not so? Now, that salty water, does it have salt? Which I mix to form it? Yes. Does it have water? Which was part of the mixture? Yes. So you see that it was neither it was not destroyed. It was not destroyed. It was not destroyed. But a new substance was formed called salty water. right? So you see, that's a typical example to prove the law of conservation of mass. Then we have another law of definite proportion. Law of definite proportion. Now, the law of definite proportion says that all pure substance samples of a chemical compound contain the same elements, contain the same what? Elements in the same proportion by mass. What are we saying? This is what we are saying. Water is made up of what? Two atoms of hydrogen and what? One atom of what? Oxygen, right? Now, if you take that water, as long as it is in its pure state, to any other place around the world, the number of atoms of hydrogen does not change. The number of atoms of what? Oxygen does not change. It remains what? The same, as long as it's what? In its pure state. That's what we call law of definite proportion. You can also put it this way: law of exact amounts. Exact amount. Exactly the number of hydrogen, exactly the number of oxygen. As long as it's pure, take it anywhere, it will maintain that. Then we have the law of what? Multiple proportion. Now, what does the law of multiple proportion say? It says if two elements form more than one compound, the masses of one element combining with a fixed mass of the other are in a simple whole number ratio. What are we saying? For example, you have, let's say if two elements form more than one compound. For example, you have NaCl, sodium chloride, right? And then you have NaCl2, sodium chloride. Is it not so? Okay, let me say NaCl and you have two NaCl. Let's write it on the board so that you have an idea of what I'm talking about. Let's prove the law of what? Multiple proportion. So let's see. You have NaCl and then you have 2NaCl. Now, you say if two elements form more than one compound, sodium and chlorine, two compounds that they are formed. They say the masses of one element combining with a fixed mass of the other are in simple whole number ratio. First of all, two elements forming different words, compound. Yeah? Now, let's say this Na now wants to combine with a fixed amount of what? Cl. This Na wants to combine with a what? A fixed amount of what? Cl. When they combine, the number of mole that they will combine in will not be half, will not be quarter, will be a whole number. Will be what? A whole number. Do you see me put half here? Do you see me put quarter here? I put what? A whole number. So, what this is saying now is that if you are reacting or mixing chemicals, the product that will be formed will not have quarter, will not have half. Yes, as long as it's one element combining with another element with that same element that is formed. Are we getting it now?